Hi everyone, this is Luyando, and in this video we'll just go over question 1b from Phy101 to the 2024 paper. This is what we'll be looking at. Okay, so in this question we are being told that there is this footballer who kicks a ball at the velocity of 25 meters per second and at an angle of 35 degrees. So to represent this visually, we're looking at something like this. Should have, let me start with the footballer first. Okay, we have a footballer here, and this guy kicks a ball at this angle, which we're given to say is 35 degrees from the horizontal plane, I would say. And he kicks this ball at a velocity of 30 of okay, kicks this ball at a velocity of 25 meters per second, right? So before we even start looking at what we're being required to solve, the best thing that we should do is let's resolve this velocity into its components. We know that this velocity has a horizontal component and it also has a vertical component. Well, we know that the horizontal component is Vx, which is equal to 25 to the cos of 35. And if we solve this, we know that it's going to give us 24.48 meters per second as our Vx. And to find the Vy, we're going to do the same. Vy will be equal to 25 to the sine of 35 degrees, which is giving us 12.95 meters per second. Okay, I've successfully resolved this into its component. Now let's look at the first part of the question. In the first part of the question, we're being asked to find the location where the ball will be after 1.2 seconds. So we're being given a time of 1.2 seconds, and we have to basically find two displacements here. We have to find the displacement in the x and the displacement in the y. So we know that the displacement in the x is what we're calling the horizontal displacement, and this is going to be x is equal to, by the formula, vxt. We know that the displacement in the x or in the horizontal axis is always equal to vx t, and we know that we have already calculated our vx to be 24.48, and our time is already given to be 1.2 seconds. And if we calculate this, we're getting a value of 24.6 meters in the horizontal axis. So this is 24.6 meters away from the footballer. And if we look at the vertical displacement, let's calculate the vertical displacement now. For the vertical displacement, we know that we are supposed to use the formula which is S is equal to ut plus 1 over 2 at squared. Now we just need to do a little bit of manipulation to this formula since we are talking about projectile motion. and this formula is going to change to be is equal to y is equal to Vy, we are talking about Vy initial, times the time minus 1 over 2 g t squared. And we know why we're getting the negative is that we are going opposite to the acceleration due to gravity. We know that the acceleration due to gravity is downwards, but if we kick the ball upwards, we are going opposite this. So that's why we are getting that negative. And replacing the values that we already have into this equation, we're going to get, we know that our Vy is 12.15 times the time, which is 1.2 minus 1 over 2. Our G is 9.8, and the time again is 1.2 meters of seconds, squared. And this is giving us what? Let me try to quickly calculate this. And we are getting 10.15 meters as our vertical displacement. So therefore, the answer is going to be equal to 24.6 meters horizontally and 10.15 meters vertically. So that is how we solve the first part of this question. Okay. The second part is asking us to calculate the velocity of the ball after 1.2 seconds. So for example, maybe it's just as an example, we can say that the ball after 1.2 seconds will be at this position. So it will have a Vx value and a Vy value as well. And what they are asking us to find is this, the velocity. So to do that, we're moving on. To do that, one thing that we have to know is that Vx does not change at any position on our trajectory. It never changes. So since we already calculated it previously to be 24.48 meters per second, it will be the same. The only the only calculation we need to find up is the Vy, and we can calculate the Vy using the equation V is equal to U. V is equal to U plus AT. Okay, V is equal to U plus AT. But since we are talking about projectile motion, we know that this this formula will undergo a certain variation. It is going to change a bit. It's going to be Vy is equal to Vy initial minus G. I explained why we're having a negative value here, times T. So let's just quickly replace. We know our initial value for Vy to be what was it? I've forgotten. Okay, it was 12.95 minus the G value is always 9.8 times the time. We are already been given the time to be 1.2. This is giving us when we perform the calculation, we are getting 2.58 meters per second. So we have found the x component and the y component of this v here. So now let us find what this v actually is. So to find what this v actually is, we are going to say v is equal to vx squared plus vy squared. And replacing in this equation, we know that our vx is 24.48 squared plus what we just found to be the value for our vy is 2.58. Then we square this. What we are getting after we perform this calculation is 20.6 meters per second. Sometimes we may be even asked to find the angle, and we know to find the angle, we are just going to say the angle theta is equal to tan inverse Vx and Vy, and we can get the answer. I'll leave this up to you, since I'm not sure whether in this question we were also asked to find the angle, but that's how we can find the angle. If we look at the last part of this question, we are being asked to find where the ball will land, like how far away from the footballer will the ball land. In order for us to find where the ball will land, we need to know the time of flight, like how long has it taken for this ball to travel from this position here up to the final position here. How long has it taken? So we know that this ball basically goes through three stages. We have stage A, and at the middle of this flight is stage B, and at the end is stage C. And we know that in an ideal situation is symmetrical. So part A to B is the same as part B to C. So the time taken for us to move from A to B will be equal to the time taken for us to move from B to C. So let us try to find the flight time which is taken for us to move from A to B. And we also need to know the velocity at B. We know at the maximum point into this flight, the velocity is going to be equal to 0. This is going to help us to calculate the flight time. Okay, so we are solving the last part. In simple terms, the flight time will be equal to, which is t, will be equal to 2 the initial velocity in the y, then divided by g will be our flight time, and replacing the values that we already have. This is 2 times 12.95, and we're dividing by 9.81, and this is giving us a value of 2.93 seconds as our total flight time. Remember, the reason why I've put these two here is because the time taken to move from this the time of flight taken for this part is just equal to the time for this part. So essentially when we don't put a 2 here, we are just finding the time taken for one part, for example, from A to B or from B to C. So if we put a T, we find the total time of flight, and our total time of flight we have calculated to be 2.93 seconds. Now, to find the total, to find where the ball will land, or in this text we can say to find the range where the ball has landed away from the footballer, and this will be equal to Vx times our total time of flight, which is equal to 24.48 times our total time of flight, which is 9.3 seconds. And let me just remove the seconds. And we have found this to be 59.9 meters. So the ball is landing 59.9 meters away from the footballer. We can approximate this to 60 meters. Don't see any harm in doing that. So that's how you go about solving given question.